In this video, before going into studying about inductive transducer principle and its operation, we should understand what is an inductor and on what principle an inductor even works. So for this, I have collected a material from a website called Electrical for You. I will share the link with you so that you can also study and get a clarity on that. So before to that, let me go through the important laws behind the working principle of inductor. Then what is an inductor? Then we can go into the inductive transducer. So in that line, let's first see what's called a Faraday's law. So Faraday's law of electromagnetic induction is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an EMF. What is that? Electromotive force. This phenomenon is called electromagnetic induction. Faraday's law states that a current will be induced in a conductor when it is exposed to changing magnetic field. Okay, so the magnetic field is referred usually by magnetic lines of force that runs from north pole to south pole. Okay, and these lines of force are called magnetic flux lines of force. And when there is a change in the magnetic flux lines of force, or when the magnetic flux lines of force gets intersected with a coil, there will be a current induced in the intersecting coil. Okay, then comes another very closely related law in electromagnetic induction, that is Lenz's law of electromagnetic induction, which states that direction of the induced current. So now there is a change in the magnetic flux lines, and because of that there is a current induced in the coil based on the Faraday's laws. So the direction of the induced current will be in such that so when there is a current in the coil, it on the other hand also produces a magnetic field. Okay, so that the induced current producing a magnetic field will oppose the original magnetic field. Okay, so this phenomenon is called Lenz's law of electromagnetic induction. The direction of the current flow can be determined by Fleming's right hand rule, that we will see in the preceding videos. Okay, so these are the two important laws. So what is the important law? Whenever there is a change in the magnetic field or magnetic flux lines, there is a current induced in a coil. Okay, and this current induced in a coil current induced in a coil produces a magnetic field, and that magnetic field will oppose the source magnetic field with a force. That force is called Lenz's force. Okay, that is okay. And so Faraday did some experiment. Okay, what is that experiment? In the experiment, takes a magnet and a coil, connects a galvanometer across the coil. As starting, magnet is at rest, so there is no deflection in the galvanometer. The needle of the galvanometer is at the center position. When the magnet is moved towards the coil, the needle of the galvanometer deflects in one direction. When the magnet is held stationary, the needle of the galvanometer returns to zero position. Now when the magnet moves away from the coil, there is some deflection in the needle, but in the opposite direction. So tabulating the conditions. So when magnet is at rest, there is no deflection in the when magnet is at rest, there is no change in the magnetic flux lines of force. So there is no current induced in the coil, so there is no deflection in the galvanometer. When the magnetic moves towards, there is a deflection in one direction. When and it is held at the same position, there is no deflection in the galvanometer. When the magnet is moved away from the coil, there is a deflection in the galvanometer. So seeing this, what you can understand is the moving magnet can be attached to a physical phenomena, and that physical phenomena can be a displacement, can be a pressure, and based on that you can calibrate the readings in the galvanometer to measure your physical quantity. Okay, so this is something that you guys need to understand. Okay, this is one of the most important law. I will share this material also, you can read it one more time. Okay, let's also see what is the important formulations and stuff. Okay, and these are some applications of Faraday's laws. As I told you, the applications in this, you can connect one side to a physical parameter, and the physical parameter can be displacement, pressure, or even force. Based on that, you can calibrate the galvanometer readings. Okay, So these are some basics that you need to understand before jumping into. I guess you guys all know this. I'm recollecting to you. These things you would have studied in your previous classes. I'm recollecting to you so that it will be easy once we enter into inductor. Okay, the next video will be on what is an inductor. Okay, thank you.